Okay, class, now we're talking about soil acidity and alkalinity. So I'm here in a greenhouse situation to talk to you about some of those things. So some of the things that cause acidity in soils are not things we experience much here in the West. So one of those things is plentiful rainfall. What happens is the CO2 is dissolved. The CO2 in the air is dissolved in water to form carbonic acid. Another thing is there's not a big accumulation of organic matter, and so non-acid nutrients are leached, such as calcium and magnesium. And so we don't have those situations very much. In our area, what does occur is there's large amounts of soil sulfur utilized. The oxidation of the sulfur creates sulfuric acid. So here in this greenhouse situation, the water coming from our well is pH way above 8. And because of that, what we have to do is we have injection tanks in the back which are injecting nutrients, which are salts. That's going to be important in this little talk that I'm giving you. But while injecting the salts into the water to feed the plants, we're also treating the water with, in this case, phosphoric acid to lower the pH. So it's a water treatment, but lots of different acids are used to lower the pH. The horticulture industry uses liquid grade acids, and so these things can be injected in liquid form. Some of the larger commercial greenhouses use like sulfuric acid. Sulfuric acid is a little dangerous to utilize, so I said we use the phosphoric acid or even sulfuric acid to treat these high pH waters. So the other thing is organic matter can lower the pH in areas of higher rainfall, and higher pH is recommended, and in higher pH, and so they recommend using lime. We don't use lime because we don't have those situations. Our organic material is not lowering the pH by much. And so that's just a situation to think about if you're in a different area. The other thing has to do with iron availability as relates to pH. And this has to do with all nutrients as it relates to pH at different levels. So you have the pH scale from 0, highly acid, rip your skin off acid, up to 14, super high alkalinity. Iron is available not at the higher alkaline type soil, at a higher pH. And so we get a lot of iron deficiency in our situations. So iron's tied up at a high pH, and then the leaves show you that because of chlorosis. Some plants grow better in acid soils, such as blueberries, azaleas, all those things, hydrangeas, that we don't grow a lot of here. But there's a big range in the middle where it's pretty good for plant available nutrient, and that's what we're trying to do, and that's what we're trying to do in the greenhouse by lowering the pH. We already talked about caliche in an earlier lesson, and that caliche is the calcium carbonate that's in the soil. If that calcium carbonate leaches to a point and it sediments in there, you can make an area where the water cannot penetrate down through that. In areas that rely heavily on irrigation only, salts can build up and accumulate. And so, like I mentioned, fertilizers are salts. And so typically in those areas before they're farmed, you would notice like plants like saltbush growing, and you see those areas in low spots where water pools seasonally and it's bringing in material from elsewhere, so salts, it accumulates, dry lake beds, etc. You see a lot of saltbush growing there, not because they like the salt, but they're adapted to grow and process that salt. And so in our greenhouse, in this tomato greenhouse, we have, let me grab a meter. This is the EC meter. We can stick this EC meter in the water to tell us how much dissolved salts. Now this is telling us how much the amount of material that is in the fertilizer that we have selected. But also, once this water is tested and we've determined the EC, if I reach down here in the greenhouse and take one of our tomato plants out, when the water comes through this material and drips out, we want the salts to move through the situation and out. So we leach, and the way you fix salt affected lands is the same way we do it in this tomato plant. We water from the top, adding fertilizers, which are salts. The plant utilizes those, and what is not used by the plant needs to leach out. It can't continue to accumulate over and over and over again. So every time we water, we measure for a 10% leach. And so if we're not getting a 10% leach, you'll start to notice buildups of salts on the surface and such. And so with this leachate, we can then take it, collect it, measure the EC, and determine what level we can fertilize the plants and at what level they're utilizing. I'll put this back here in the greenhouse. And so in outdoor field situations, it's the same thing. If you're relying just on water and fertilizer additions to your specific crop, then you'll need to once in a while flush with a larger amount of clean water without the salt. All right, thank you for checking out this lesson.